Hello, and welcome to this short video that demonstrates infeasibility analysis capabilities within Baron. As developers of optimization models must know very well, our optimization models are often termed infeasible by solvers. While this is useful information, it does not help in determining what is the cause of the infeasibility. In such a situation, it would be useful to know if the cause of infeasibility is a mistake in the model or if it is present in the underlying system. Identification of an irreducible inconsistent set, abbreviated as an IIS, can help provide this information. In this video, I will show how Barron's implementation for identification of an IIS can help in this situation. As the audience may be aware, Barron is available under many environments, including GAMS, AIMS, AMPL, Pyomo in Python, JUMP in Julia, YALMIP, and MATLAB. Barron can also be used through its own modeling language. In this short example, I will be using Barron directly through its modeling language. The example is the classic Himmelblau problem from literature with 5 bounded variables and 6 constraints. It's modeled in Barron's modeling language through suitable declaration of identifiers such as options, variables, equations, lower and upper bounds, and the constraint definitions themselves. The model can be solved by invoking Barron on the command line. Barron solves it instantly, this being a small model. Now suppose we made a mistake in transcribing the model. Typos in codes are not uncommon, even with the most skilled developers. I introduced a typo in this model by replacing the first addition sign in equation E2 with a product sign. Running this model again leads to infeasibility. Analyzing for such typos may not be easy and perhaps not even possible if we're dealing with large models with millions of variables or constraints. Luckily, the IIS identification capabilities of Barron can come to the rescue in this situation. We will invoke the infeasibility diagnosis capability in Barron by setting the option comp_IIS to 1. Comp_IIS set to 1 invokes the fast heuristic for IIS isolation. Barron also implements 4 other algorithms which can be invoked by suitably setting comp_IIS. More information can be obtained from the Barron manual. If we run the model again, we can see that Barron again finds the model to be infeasible. However, Barron now continues after the infeasibility status and returns an IIS to us. This IIS is returned in Barron's results file named res.lst by default. Looking at the IIS returned, we can see that Barron has found equation E2 along with the variable bounds on x1, x2, and x5 as a part of the IIS. This is great since Barron is able to successfully identify E2 as a part of the issue, the equation where we introduced a typo. Of course, this infeasibility can be resolved by correcting E2 or by updating the bounds on x1, x2, and x5. As an optimization solver, Barron cannot determine what is the exact correction that is required. That would have to be determined by the modeler based on their respective needs. However, being able to narrowly identify a small part of the model can be vital, especially if the model under consideration is very, very large. In this way, the IIS identification in Barron can help focus attention and speed up diagnosis of infeasibilities. More information can be obtained from the Barron manual and a corresponding publication in the literature.